September 1943, at the German military testing facility in Kummerdorf, approximately 30 kilometers from Berlin, a group of engineers from the Wehrmacht's Ordnance Directorate gathered around a table. Upon it lay a captured American projectile, which they had just disassembled. Silence hung in the air, born not of admiration, but of sheer disbelief. Chief Engineer Hans Schneider, a specialist in anti-tank weaponry, held an empty copper cone in his hands. He turned it, letting the light play across its surface, searching for some intricate design. Yet, all he saw was a sheet of metal expertly folded into a conical shape. "This is impossible," he finally stated. "This cannot pierce 150 millimeters of armor." Yet, it did. The Germans knew this with certainty, for the projectile had been recovered from a destroyed Tiger tank at Cerno, a tank boasting 100 millimeters of frontal armor. The shell had passed straight through. Most astonishingly, this was no secret, miraculous weapon. It was a mass-produced munition, churned out by the Americans by the thousands. No complex mechanisms, no exotic alloys, merely explosive and a copper cone. How could it possibly function? The narrative of the shaped charge is a testament to physics triumphing over engineering, demonstrating how a simple phenomenon, understood since the 17th century, transformed into one of the most formidable weapons of the Second World War. It also highlights how the Germans, despite possessing the theoretical knowledge of the effect, were outpaced by the Americans in its practical application. By 1942, the United States had commenced large-scale manufacturing of shaped charge rounds for both bazookas and cannons. By the close of 1943, over 2 million such munitions had been produced. Germany possessed superior engineers and a more profound theoretical understanding, but the Americans offered a straightforward solution coupled with immense industrial capacity. When German specialists received the initial examples of American bazooka models M6A1 and M9A1, they anticipated encountering sophisticated mechanisms, akin to their own designs, featuring precision cones, specialized alloys, and elaborate fuses. Instead, they discovered components that could have been fabricated in a small country workshop. This realization shocked them more than the projectile's penetration capability itself. The German war industry in 1943 was already stretched thin. Every new weapon demanded specialized machine tools, skilled laborers, and rare materials. The Americans, however, had devised a munition that could be manufactured at a pace exceeding tank production in substantial quantities and with relative ease. This is not the tale of a solitary genius conjuring a miracle. It is a story of pragmatism versus perfectionism, illustrating how, in warfare, victory belongs not to the creator of the absolute best, but to the one who can produce something sufficiently good 1,000 times faster. In 1888, within the laboratory of the United States Artillery School at Fort Munroe, Virginia, Captain Charles Munroe conducted a seemingly simple experiment that would, in time, fundamentally alter the nature of combat. Though its full significance would not be grasped for another half-century, Munroe was investigating explosives, driven by the prevailing question for artillerymen of that era: how to extract greater energy from smaller explosive charges. He placed a block of dynamite on a steel plate and detonated it, resulting in a modest crater. Subsequently, he took an identical block of dynamite, this one bearing the manufacturer's trademark, a small, recessed indentation. Munroe positioned this charge with the indented surface facing down and detonated it. The outcome was astonishing. Instead of a crater, the steel plate bore a nearly perfectly circular, deep, and precise hole, as if it had been drilled. Surrounding the hole, there was minimal damage. Munroe repeated the experiment, achieving the same result. When the surface of an explosive charge features a cavity directed towards the target, the explosive energy concentrates into a singular point. Rather than dispersing, it strikes with a focused, hammer-like force, capable of penetration. He published his findings in the Journal of the United States Artillery in 1889, titling his paper, "The Effect of Cavity Formation in Explosives, the Munroe Effect." The paper was read, noted, and then largely forgotten for decades. In 1889, the practical application of this discovery in battlefield realities remained elusive. There were no vast armor plates to pierce. Naval vessels and fortresses could be adequately addressed by conventional projectiles. The Munroe effect persisted as a scientific curiosity, a fascinating physical anomaly devoid of immediate practical utility. Yet, physics remains immutable, patiently awaiting its opportune moment. And when tanks began to appear on the battlefields of the First World War, this effect would be remembered. In 1911, within Imperial Germany, Eugen Neumann, an Austrian engineer, was working to enhance explosive charges designed for the demolition of concrete fortifications. Upon reading Munroe's article, he immediately recognized its practical potential. Neumann embarked on his own series of experiments, moving beyond mere replication of Munroe's tests. He advanced the concept by shaping the cavity into a cone. The results were significantly improved, producing a narrower and deeper explosive jet. Neumann meticulously measured its velocity, exceeding 7,000 meters per second, a speed surpassing any projectile of that era. In 1914, he patented his invention, patent number 2727 of the Austro-Hungarian Empire, for a hollow explosive charge for the destruction of armor plates. However, the outbreak of the First World War preceded the full bureaucratic processing of the patent. The German army was occupied with more pressing priorities, focusing on heavy, powerful artillery for sieges and fortress assaults. Shaped charges were considered experimental and low priority. Following the war, Neumann's invention was once again relegated to obscurity. Germany's defeat led to the dissolution of its army under the Treaty of Versailles, and research into new weaponry was forbidden. But the engineers did not vanish. They retained their knowledge and their notes. When rearmament commenced in the 1930s, old documents were retrieved from storage. In 1935, Franz Thomann, an engineer at Rheinmetall Borsig, revived the research on the Neumann-Munroe effect. Tanks had emerged as a significant military force, creating an urgent demand for weapons capable of neutralizing them. Thomann developed the first experimental shaped charge projectile for an anti-tank gun. This projectile featured a conical copper liner and a TNT charge. Testing demonstrated that the round could penetrate 70 millimeters of armor, surpassing any armor-piercing round of its caliber. It appeared that Germany held a strategic advantage, having been the first to grasp the technology's potential, with theory, engineers, and an industrial base all seemingly on their side. Yet, this is where Germany's inherent problem manifested: perfectionism. In 1940, at the Aberdeen Proving Ground in Maryland, United States, Swiss engineer Henry Mohopt presented his invention to American military officers. Mohopt had been developing shaped charges in Europe since 1935. Upon the commencement of the war, he immigrated to the United States, bringing his designs with him. His device was remarkably simple: a metal tube containing TNT at the nose and a copper cone. It lacked complex fuses or elaborate mechanisms capable of detonation by an ordinary striker. The American officers met the idea with skepticism, deeming it far too rudimentary. However, Mohopt insisted on a demonstration. They procured captured French tank armor, 80 millimeters of hardened steel. Mohopt positioned the charge and detonated it. The armor was pierced, leaving an almost perfectly round hole, 5 centimeters in diameter. General Gladian Barnes, head of technical services, observed the result and declared, "We need this. How many of these can you produce in a month? Mohop's response was, "The question is not about me. The question is about your industry." This is where the United States showcased its true strength. While the American war industry in 1940 might not have been the most sophisticated globally, with Germany holding advantages in steel production, engineering education, and manufacturing precision, the Americans possessed something else: scale and a pragmatic approach to mass production. By the end of 1941, General Electric, Westinghouse, and several other firms had established serial production of shaped charges. Without resorting to ultra-precise machine tools, they stamped copper cones almost like common tin cans, filled them with TNT, and assembled them in vast quantities. In June of 1942, the first bazookas, Model M1, entered service. With a 60mm caliber, a projectile weight of 1.5 kilograms, a range of 100 meters, and the ability to penetrate 80 millimeters of armor, it was not an engineering masterpiece, but it was effective and could be produced by the thousands. By the end of 1942, the United States was manufacturing 5,000 bazookas per month. By mid-1943, this figure had risen to 15,000 per month, with each unit costing a mere $18, less than most rifles. Germany remained unaware of this burgeoning threat, but their awareness was imminent. In November of 1942, during Operation Torch, the Allied landings in North Africa, American troops deployed the M1 bazooka en masse against German tanks for the first time. Near the town of Tebessa, Algeria, a German Panzer IV advanced slowly down a narrow thoroughfare. Commander Kurt Kanarum felt assured, his 50mm frontal armor capable of withstanding any American anti-tank rifle round, with no enemy artillery in sight. Suddenly, a flash emanated from a window of a nearby house, approximately 40 meters distant. Something streaked towards the tank, unlike a conventional shell, being too slow. It resembled a rocket. Impact. An explosion followed, not deafening, but sufficient to alert the crew. Kanaram awaited a damage report, but none arrived. Instead, came the cries of the driver-mechanic, followed by smoke and then flames. The crew bailed out, 2 wounded, 3 surviving. Kanaram could not comprehend the event. The tank was ablaze, yet externally, there were almost no visible holes, as if the armor had been breached by an unseen force that ignited the interior. Following the engagement, engineers examined the disabled Panzer IV. In its frontal armor, a neat hole, 4 centimeters in diameter, was discovered, its edges appearing melted. Behind the armor, a cone of molten metal had penetrated the engine compartment, igniting the fuel tanks. No shell fragments were found, only residual traces of copper and explosive. "What was that?" Kanaram inquired in the hospital. "We do not know," they replied, "but the Americans have something new." Reports of this incident swiftly ascended through the ranks to the Africa Corps headquarters and subsequently to Berlin, reaching the Ordnance Directorate. Upon reading the report, the German engineers were incredulous. Rocket weapons of 60mm caliber, capable of penetrating 80 millimeters of armor from 40 meters, seemed to defy known ballistic principles. Yet, further reports arrived, one after another, from Tunis, Algeria, and Morocco. The Americans were deploying an unknown weapon on a large scale. Infantrymen carried these weapons on their shoulders, emerging from cover, firing, and disappearing. The Ordnance Directorate issued a critical order: acquire a captured example at any cost. In January of 1943, near the town of Speyitla, Tunisia, a German reconnaissance unit was tasked with locating an American position and recovering as much equipment as possible. The operation took place under the cover of darkness. The Germans assaulted an outpost of the 1st Infantry Division, engaging in a brief firefight. The Americans withdrew, leaving some equipment behind. Among the captured items were 2 M1 bazookas, 14 M6 rounds, and a crate containing operational instructions. The weapons were urgently flown to Berlin under the escort of an OKW officer. In February of 1943, at the Kummerdorf Proving Ground, a contingent of engineers from the Ordnance Directorate unboxed the captured equipment. Their initial surprise was the weight of the bazooka, weighing 5 9/10 kilograms, almost negligible. The German Panzerbuchse 39 anti-tank rifle weighed 12 kilograms and could barely penetrate 30 millimeters of armor. The second surprise was the construction. The bazooka was essentially a simple tube, 2 steel semi-cylinders joined by clamps, a rudimentary firing mechanism, basic front and rear sights, a wooden handguard, and no precise mechanics or optics. It lacked even a stock, featuring only 2 grips. "Is this homemade?" one engineer inquired. "It is mass-produced," responded the unit leader, Major Ernst Otto Kunel. "Observe the markings: serial number, factory marked, General Electric." They then examined an M6 round, which was even simpler: a metal tube, stabilizers, and a nose cone fashioned from copper. Its weight was 1 5/10 kilograms, and its length was 54 centimeters. Kunel carefully unscrewed the nose section, revealing a TNT charge and a copper cone. The cone was thin, exhibiting visible stamping marks, indicating no hand finishing. "They manufacture these on ordinary stamping presses," he remarked, "much like tin cans." The engineers exchanged glances. In Germany, shaped charges were produced with meticulous precision, the cones turned on specialized lathes, each undergoing rigorous quality control, an expensive and time-consuming process. The Americans, in contrast, stamped them out as if they were mere nails. And, most disconcertingly, it worked. In February of 1943, at the Kummerdorf firing range, the Germans mounted captured armor, an 80mm plate from a French B-1 tank. They positioned a bazooka at a distance of 50 meters and loaded an M6 round. Oberleutnant Werner Oswald, an artillery specialist trained to operate the Panzerbuchse, the German analog still under development, shouldered the bazooka. It felt lighter and simpler to handle. He aimed, squeezed the trigger, and the round left with a quiet hiss. The rocket motor burned for 0.3 of a second, propelling the projectile on a straight trajectory, akin to a bullet rather than a conventional artillery shell. Impact, explosion, smoke. The engineers rushed to the target. In the armor plate, a clean circular hole, 5 centimeters in diameter, was visible. The edges were beveled inward, melted. Approximately 1 meter behind the plate stood a wooden panel, scorched and pierced by fragments of molten metal. Kunel measured the penetration depth, 140 millimeters. "That exceeds the penetration of our 75mm Pak-40, he stated quietly. The Pak-40 was the premier German anti-tank gun of 1943, weighing 1,425 kilograms, requiring a crew of 5 men, and firing armor-piercing rounds capable of penetrating 120 millimeters of armor at 500 meters. The bazooka, however, weighed only 6 kilograms, could be operated by a single soldier, and achieved greater penetration from 50 meters. The Germans then fired 10 more shots, with consistently similar results. Penetration of 70 to 80 millimeters at obliquities up to 30 degrees, and up to 140 millimeters on direct hits. They dismantled a second round, meticulously photographing each component, weighing the parts, analyzing the explosive composition, TNT with an RDX admixture, measuring the copper liner thickness at 0.8 millimeters. The findings were compiled into a comprehensive 48-page report, concluding that the Americans had developed a weapon simpler than any German equivalent, costing 10 times less to produce, 3 times more effective than their anti-tank rifles, and capable of mass manufacturing without specialized tooling. Germany was losing this race because, while they pursued perfection, the Americans embraced good enough and initiated mass production. In March of 1943, in Berlin, at the Reich Ministry of Armaments, Albert Speer reviewed the report on the captured bazooka. Speer, an architect by training rather than an engineer, understood industry and perceived a stark reality. Germany was losing the war not only on the battlefield, but also on the production lines. The United States was producing 2,000 tanks per month, while Germany managed only 600. The United States manufactured 15,000 bazookas a month. Germany produced none. Speer summoned Kühnel. "Can we replicate this?" he inquired. "Yes," Kühnel replied, "but there is a problem." The issue, he explained, was not technological, but philosophical. German engineers were already developing their own shaped charge launcher, the Panzerbuchse, designation Raketenpanzerbuchse 54. It was technically superior to the bazooka, with an 88mm caliber compared to the bazooka's 60mm, offering 160mm of penetration versus 80, a greater range and superior sights. However, it was more complex and heavier, 11 kilograms instead of 6, and significantly more expensive, 70 Reichsmarks compared to 30. "Why can we not simply copy the American design?" Speer pressed. "Because our engineers will not accept good enough," Kühnel answered. "They strive for perfection." This, he elaborated, was Germany's critical failing. The Third Reich harbored a reverence for engineering excellence, demanding that every design be a masterpiece. The Tiger tank, while one of the finest of its era, was intricate and costly. The Messerschmitt Bf 109 was an exceptional fighter, but required highly skilled pilots. The Sturmgewehr 44, a revolutionary weapon, suffered a 2-year delay due to bureaucratic hurdles. The Americans, however, adopted a different approach. They produced the Sherman tank, not perfect, but reliable and mass-produced. The P-51 Mustang was an easily manufactured fighter. The M1 Garand rifle could be serviced by any soldier. The bazooka epitomized this philosophy, not the best, but good enough, and produced in overwhelming numbers. Speer understood this, but found himself unable to alter the system. German industry was geared towards quality, not quantity, and retooling would necessitate halting production for months, a luxury the nation could not afford with the war already in progress. Thus, he issued the order to make the Panzerbuchse better, more complex, more expensive. The initial prototypes reached the front in August 1943. While indeed superior to the bazooka, by that time, the Americans had already manufactured over 200,000 bazookas. In September of 1943, during Operation Avalanche, the Allied landings at Salerno, Italy, American and British units stormed the beaches. German forces counterattacked with tanks. On the morning of the 9th of September, along the coast south of Salerno, Company Charlie of the 36th Infantry Division had established defensive positions on the outskirts of Paestum. They were equipped with 3 M9A1 bazookas, an improved variant of the M1, boasting a 60mm caliber and an effective range of up to 180 meters. At 7:30 a.m., the Germans launched a counterattack consisting of 4 Panzer IVs and 2 Tigers, supported by infantry. Corporal James Connor spotted a Tiger slowly emerging from behind a house approximately 120 meters away. The lieutenant's order rang out, "Bazookas on the Tiger." Connor knew the Tiger's frontal armor measured 100 millimeters. On paper, the M9A1 bazooka could penetrate up to 120 millimeters, but combat reality often differed. He loaded an M6A3 round, broke cover, and sprinted to a ruined wall to reduce the distance. The effective range was now about 80 meters. The Tiger began to slowly rotate its turret, its 88mm gun searching for a target. Connor shouldered the bazooka, aiming not at the heavily armored front, but at the flank, where the armor was approximately 80 millimeters thick. He pulled the trigger. The round traveled through the air for about 2 seconds, striking the midship between the road wheels. A brief, not excessively loud explosion occurred, and the Tiger halted. Smoke billowed from the turret, and the crew abandoned the vehicle. Later, after the position was secured, engineers inspected the destroyed tank. In its side, a neat hole, about 6 centimeters in diameter, was found. The shaped charge jet had passed through the armor, pierced the fuel tank, and ignited the ammunition storage. A Tiger tank cost 250,000 Reichsmarks, a bazooka $18, the projectile $2. The exchange appeared fundamentally unfair, yet war recognized no such equity. In October of 1943, at the Kummerdorf Proving Ground, German engineers received a knocked-out Tiger from Salerno to ascertain how an American 60mm caliber projectile had penetrated an 80mm side plate. Engineer Fritz Heinemann led the investigation. Under microscopic examination, the edges of the perforation appeared melted and curled inward. This was not mechanical punching, it was thermal cutting. The metal had not been smashed, but rather severed by a heated jet. Heinemann stated his conclusion plainly. The shaped charge jet acted like a supersonic cutter, reaching temperatures of approximately 5,000 degrees Celsius, velocities up to 8,000 meters per second, and pressures of roughly 500,000 atmospheres. Under such extreme conditions, armor behaved like a liquid, yielding rather than cracking. The jet passed through the plate as easily as a knife through softened butter. The crucial question remained, what exactly generated this jet? Heinemann replicated Munroe's experiment, using a TNT charge with a copper liner. High-speed filming, capturing approximately 5,000 frames per second, revealed the detonation front traveling from the base to the nose, compressing the copper liner. Under hundreds of thousands of atmospheres of pressure, the copper flowed plastically, the liner collapsed, and ejected forward a narrow jet of heated metal. This jet, thin, approximately 5 millimeters in diameter, traveled at up to 8 kilometers per second. Upon impact with the armor, it generated a pressure that the plate could not withstand. The thinner the liner, the faster the jet. The longer the cone, the deeper the penetration. The Americans had selected a copper liner thickness of about 0.8 millimeters, the minimum at which stamped copper retained its structural integrity. Any thinner, and the liner would deform during stamping. Any thicker, and the jet's velocity would decrease. The Germans could machine a liner around 0.5 millimeters, achieving greater precision and a more aesthetically pleasing finish, but at 3 times the cost and 3 times the production time. Heinemann wrote in his report, "The Americans have achieved an optimal balance between effectiveness and manufacturing simplicity. Their technology is not perfect, but it is sufficient, and that precisely constitutes their advantage." The report was forwarded to the Ministry of Armaments, reviewed, and ultimately, nothing was altered. Shifting course implies acknowledging a fundamental flaw, a step nobody seems willing to take. December of 1943, at the Aberdeen Proving Grounds in the United States, engineers are enhancing the bazooka, not because it's inadequate, but to swiftly address identifiable vulnerabilities. The primary concerns with the M1 and M9A1 models included significant backblast, where a burst of flame from the tube upon firing could injure the operator, a limited practical engagement distance of around 100 meters, noticeable degradation in accuracy beyond 50 meters, and a protracted reload sequence of approximately 15 seconds. The strategic approach remained consistent. Rather than striving for unattainable perfection, the objective was to rapidly and cost-effectively mitigate the most pressing shortcomings. January of 1944 saw the introduction of an improved M9A1 variant, featuring a refined blast deflector and enhanced flame suppression, alongside an updated M6A3 projectile incorporating a more efficient liner. This new munition was estimated to achieve a penetration depth of about 150 millimeters. By March of the same year, an experimental M18, measuring 57 millimeters in caliber, emerged. It was lighter than the M9A1 and offered comparable penetration capabilities, yet it did not enter mass production, as the M9A1 was deemed sufficiently effective. In May of 1944, the M20 Super Bazooka was developed, boasting an 89 millimeter caliber, similar to the German Panzerschreck. It could penetrate up to 280 millimeters of armor and had a range of approximately 300 meters. However, its substantial weight, around 15 kilograms, rendered it impractical for widespread deployment. Consequently, the M20 remained largely experimental. The Army concluded that the M9A1 adequately addressed the majority of operational requirements, finding no merit in further complicating matters. By June, coinciding with the Normandy landings, American forces possessed approximately 60,000 M9A1 bazookas. Each infantry company was equipped with 3 to 5 units, and every platoon received comprehensive training. The German military, meanwhile, had around 8,000 Panzerschrecks. While technically superior, their scarcity was a critical disadvantage, being 8 times fewer in number than their American counterparts. The battlefield paradox was straightforward. A Panther tank in open terrain typically outmatched a Sherman. The Panther's 75 millimeter cannon possessed an effective range of up to 2 kilometers, whereas a Sherman struggled to penetrate the Panther's frontal armor even from 500 meters. However, the dynamic shifted dramatically within urban environments. In confined streets, a Panther might encounter 3 American soldiers armed with bazookas. One would fire, while the other 2 reloaded swiftly. A Panther tank represented a significant investment of 117,000 Reichsmarks and months of manufacturing effort. 3 bazookas, costing approximately $60, could be produced in a single day through stamping processes. This was not a contest of equitable duels. War is fundamentally about outcomes. February of 1944 found the front lines static at Anzio, Italy. Streets transformed into narrow channels and defensive strongholds. The Germans deployed tanks as mobile pillboxes, with Panzer IVs and Panthers emerging from behind rubble, firing a shot before retreating. The Americans responded with bazookas. However, within the urban setting, a new peril emerged. At engagement distances of 20 to 30 meters, the backblast could ricochet off walls, posing a severe burn risk to the gunner. Captain Michael Pitt, commanding Baker Company of the 3rd Infantry Division, proposed a pragmatic solution: firing from second-story windows. The bazooka operator would be positioned on the 2nd floor, with the loader beside him. The targeted tank would be situated below, beneath the window ledge. On the 13th of February, 1944, along Via Anziate, a German Panther tank advanced cautiously down an alley. Perceiving no immediate threat, the Americans had vacated the ground floors. Private Karl Renner, a 22-year-old soldier, positioned himself at an upper-story window with an M9A1. His sights were fixed on the turret roof, the thinnest section of armor, approximately 40 millimeters thick. He aimed and fired. The projectile descended almost vertically, struck the roof, penetrated the interior, and detonated. The Panther came to a standstill, its turret immobile, its crew deceased. This tactical innovation became standard procedure in urban combat, with bazookas effectively attacking tanks from above. Tanks engineered for open field engagements proved susceptible to top-down assaults. By May, as the Allied forces entered Rome, bazookas had been responsible for destroying more German vehicles than Sherman tanks and anti-tank guns combined. Approximate statistics for the United States Fifth Army in Italy from January to May of 1944 detail 347 German tanks destroyed by bazookas, 198 by Sherman tanks, 156 by anti-tank guns, and 89 by aviation. The bazooka evolved into an emblem of American infantry prowess, not due to inherent superiority, but its widespread availability. Nearly every platoon possessed at least one, and every soldier understood that the presence of a tank on the street still offered a fighting chance. German infantry, conversely, often lacked such recourse. In August of 1944, Germany finally acknowledged its losing position in the shaped charge arms race. The Panzerschreck, while effective, was catastrophically scarce. A more straightforward, less expensive solution was urgently needed, one feasible even for an industrial base already weakened by relentless bombing. Dr. Heinrich Langer of Hassag proposed a radical departure, a disposable launcher. This concept eschewed a durable tube for prolonged service, complex sighting mechanisms, and any notion of reuse. It was envisioned as a simple charge within a tube, to be fired and then discarded by the soldier. This idea initially startled German engineers, who viewed disposable weaponry as an unacceptable waste and an affront to the meticulous quality standards that characterized German engineering. However, Langer remained unswayed by emotional arguments, focusing instead on the empirical data. A Panzerschreck incurred a cost of 70 Reichsmarks, weighed 11 kilograms, and required approximately 8 hours for production. His disposable variant, conversely, was projected to cost 30 Reichsmarks, weigh around 5 kilograms, and be manufactured in just half an hour. Albert Speer, after reviewing the projections, gave his approval. Production of the Panzerfaust, specifically the FA-30 model, commenced in August. The design was deliberately crude and uncomplicated: a steel tube, 44 millimeters in diameter and roughly 80 centimeters in length, containing a propellant charge. Externally, it was fitted with a large, shaped charge warhead, approximately 100 millimeters in diameter. The total mass was 5 1/10 kilograms, offering a penetration capability of up to 200 millimeters of armor. Its effective aimed range was limited to about 30 meters. The aiming mechanism was rudimentary, featuring a simple front sight, a safety pin, and a trigger lever on the tube. Soldiers were instructed to remove the safety, aim, and fire, subsequently discarding the spent tube. The production target was set at 200,000 units per month, escalating to millions by the time of capitulation. The Panzerfaust's simplicity, stemming from its single-use nature, eliminated the need for a robust, long-lasting tube, conserved metal, and dispensed with precision sights and expensive finishing processes. When American forces first encountered the Panzerfaust in France during the autumn, the reaction was mixed. The concept of disposable weaponry felt inherently crude. Nevertheless, at close ranges, around 30 meters, it could penetrate any American tank. Crucially, by this point, nearly every German infantryman was equipped with this weapon. The irony was stark. Germany, at long last, was adopting the core lesson of the bazooka. They abandoned the pursuit of an idealized weapon in favor of a sufficiently effective, mass-producible solution. However, this realization arrived far too late. By August of 1944, the war in Europe was already turning decisively against Germany. Fronts were retreating, factories were subjected to nightly bombing, and raw materials were scarce, even for tank production. By this juncture, the Americans had manufactured approximately 460,000 bazookas. Germany, meanwhile, was only just beginning to ramp up mass production of its Panzer variants when time had effectively run out. The 6th of June, 1944, marked D-Day and the Normandy landings. American units stormed Omaha and Utah beaches. Each infantry company carried bazookas, but their utility on the beaches was minimal. The primary obstacles were concrete fortifications and machine gun nests, not armored vehicles. A shaped charge proved highly effective against steel, but was largely ineffective against meter-thick concrete walls. Bazookas would become significant once the beachhead expanded and tanks began to appear in larger numbers. On the 18th of June, near Saint-Lô-Constant, approximately 15 kilometers inland from the coast, Able Company of the 505th Parachute Infantry Regiment established defensive positions on the outskirts. Facing them were 2 Panther tanks and a platoon of German infantry. Sergeant Leonard Funk identified the first Panther emerging from behind a farm building at a distance of 200 meters. This range exceeded the reliable engagement capability of the bazooka, whose true effective distance was around 100 meters. He patiently waited. The Panther advanced and fired, sending debris showering down and bursting sandbags in a wave. At 150 meters, it was still too far. 100 meters was ideal. Funk raised his M9A1. Private John McKay, the loader, inserted an M6A3 round and gave a brief tap on Funk's shoulder, signaling readiness. The target was the lower hull of the Panther, where the armor was approximately 40 millimeters thick. With a squeeze of the trigger, the shot was fired. The projectile's flight took roughly 1 2/10 seconds. It struck the side of the tank just below the turret, followed by an explosion and a cloud of smoke. The vehicle rolled a few more meters before coming to a halt. Initially, there was uncertainty. "Did we miss?" McKay asked. "We hit," Funk calmly replied. "Watch." White, then black smoke billowed from the hatches. The crew bailed out through the top. The Panther ceased movement and subsequently erupted in flames. The second Panther, witnessing this, retreated. Later, American forces examined the tank's side, discovering a neat hole approximately 7 centimeters in diameter. The shaped charge jet had penetrated the armor, reached the ammunition storage, and ignited the shells. The resulting internal explosion tore the tank apart from within. Many German vehicles met a similar fate in Normandy, not primarily from tank guns or aerial bombardment, but from infantry armed with bazookas, positioned at the opportune moment and location. Tank crews of the Third Reich increasingly dreaded not the Sherman tanks themselves, but the American infantry fighting alongside them. By September of 1944, the United States Army Ordnance Department was compiling an internal report on the efficacy of anti-tank weaponry in Europe. The document, presented in dispassionate statistical language, reflected the intensity of battles fought from June through August. Statistics for France during June to August of 1944 revealed 412 German tanks and self-propelled guns destroyed by bazookas and other handheld anti-tank means, 347 by American tanks, 289 by anti-tank guns, and 198 by aviation. Mines accounted for 84, artillery for 76, and other means for 62, totaling 1,468 vehicles. A bazooka, an infantryman's weapon costing $18, was responsible for destroying more German tanks than the Sherman, which cost approximately $50,000. However, this success came at a significant cost. The losses of bazooka operators per 100 tanks knocked out were 43 killed and 87 wounded, totaling 130. In contrast, Sherman crew losses per 100 tanks destroyed were 12 killed and 31 wounded, totaling 43. While the bazooka proved highly effective, it also presented immense danger to the individual operating it. Engaging a tank at ranges of 50 to 100 meters demanded either extraordinary courage or sheer desperation. Sergeant Leonard Funk, the same soldier who had disabled a Panther near Saint-Lô-Constant, wrote home describing the experience. "Firing a bazooka at a tank is like standing on the tracks, waiting for the train to come close enough for you to throw a stone. Throw too early, and you miss. Throw too late, and it crushes you." Yet soldiers continued to fire because the bazooka offered a chance. Without it, an infantryman facing a tank was effectively helpless. With it, he possessed a means of response. The psychological impact was profound. Tank crews felt it acutely. Captain Hans von Luck, a battalion commander in the 21st Panzer Division, recalled, "In Russia, we feared the T-34 and its guns. In France, we feared every window, every bush, every ruined wall, because a bazooka could fire from there. And if it fired from 30 meters, armor would offer no protection." Tactics consequently shifted. German forces began to avoid towns lacking substantial infantry screens, skirted narrow streets, and fired at every suspicious window. This maneuvering slowed their advance and diminished their operational effectiveness. Germany, by this point, was running out of time. December of 1944 witnessed the Ardennes Offensive, Germany's final major attempt to alter the course of the war in the West. Over 1,000 tanks were committed to this operation, including King Tigers, boasting 150 millimeters of frontal armor. On the 16th of December, German forces breached the Ardennes, targeting a vulnerable sector. The Panzerwaffen pushed approximately 80 kilometers deep. American units retreated, but the bazookas moved with the infantry, engaging tanks in villages and towns. In Bastogne, on the 20th of December, the 101st Airborne Division found itself encircled. They possessed around 60 M9A1 bazookas and approximately 500 rounds of ammunition. The Germans launched an assault on the town, with Panthers and Panzer IVs entering the streets. These were met with concentrated fire from windows, basements, and behind barricades. On the first day of the engagement, the Americans disabled 18 enemy vehicles, 11 of which were attributed to bazooka fire. The critical issue became ammunition. By the 22nd of December, fewer than 100 rounds remained for the entire division. On the 23rd, the skies cleared, and United States aircraft delivered vital supplies, including food, medicine, ammunition, and an additional 400 bazooka rounds. Soldiers embraced the dropped containers with relief. The bazooka represented their best hope for survival. By the end of December, the offensive had stalled. The Germans sustained hundreds of vehicle losses, with precise figures lost amidst the winter forests. Repeatedly, the word bazooka appeared in field reports. One particular incident became legendary. On the 24th of December, in Chinon, Private Robert Max, a 19-year-old soldier, took position with a bazooka in the ruins of a church. A King Tiger, a colossal 68-ton tank with 150 millimeters of frontal armor, rumbled down the road. Max knew his M6A3 round could penetrate approximately up to 150 millimeters. The frontal armor was insurmountable. The side plates, however, were only about 80 millimeters thick. He waited until the tank lumbered past, then stepped onto the road behind it. The distance was approximately 20 meters. He aimed at the rear plate, where the fuel tanks were located and the armor was thinner. He fired. The projectile struck the rear plate, and the shaped charged jet punched through, reaching the tank's interior. The King Tiger exploded with such violence that the shock wave threw Max to the ground. For this action, he was awarded the Silver Star. Most importantly, he remained alive because he possessed a bazooka. By January of 1945, Germany was clearly losing. The Red Army stood 60 kilometers from Berlin, and the Americans had reached the Rhine. Yet factories continued to churn out Panzerfausts by the millions. By the time of capitulation, approximately 6 7/10 million launchers of various models had been produced. The Panzerfaust 30 had an effective aimed range of about 30 meters, the Panzerfaust 60 up to 60 meters, the Panzerfaust 100 up to 100 meters, and the Panzerfaust 150 was an experimental, reusable version. Every German infantryman, even those in the Volkssturm, possessed anti-tank capabilities in their hands, but it no longer altered the war's trajectory. The fundamental problem was not a lack of effective weaponry, but the squandering of strategic time. When the Americans initiated mass bazooka production in 1942, they gained a 3-year advantage, a period during which their infantry possessed a viable countermeasure to German tanks. By 1944 to 1945, when the Germans finally fielded substantial numbers of Panzer variants, it was definitively too late. The Allies controlled the skies, their supply columns stretched endlessly, and artillery systematically neutralized resistance. A Panzerfaust, in the hands of a militia member, could disable a single vehicle, but it could not halt an entire army. The chilling irony lay in the fact that the Panzerfaust was technically superior to the bazooka. It offered greater penetration, approximately 200 millimeters compared to roughly 150, featured simpler construction, was single-use, and was significantly cheaper, costing around 30 Reichsmarks versus the bazooka's approximately $50. The Germans had learned their lesson and adopted a strategy of simple, inexpensive mass production. However, their understanding came 3 years too late, and those 3 years represented the critical factor in their defeat. Europe was all but lost. The Panzerfaust emerged as Germany was in retreat on all fronts, its factories subjected to nightly aerial bombardment, and its raw material supply severely depleted, even for tank production. By this juncture, the Americans had already manufactured approximately 460,000 bazookas. The Germans' decision to ramp up mass panzer production occurred at a moment when time itself had turned against them. The 6th of June, 1944, D-Day, the Normandy landings. American forces landed on Omaha and Utah beaches. While each infantry company carried bazookas, their effectiveness on the beaches was negligible. The defenses consisted of concrete bunkers and casemates, not armored vehicles. A shaped charge could penetrate steel, but was largely ineffective against a meter of concrete. The bazookas would demonstrate their true value later, once the beachhead expanded and German tanks began to appear in larger numbers. On the 18th of June, at Saint-Lô-Constant, approximately 15 kilometers from the coast, Able Company of the 505th Parachute Infantry Regiment dug in on the town's periphery. Opposite them were 2 Panther tanks and a platoon of German infantry. Sergeant Leonard Funk observed the first Panther emerge from behind a farm building at a range of approximately 200 meters. This distance exceeded the bazooka's effective engagement range, which was about 100 meters. He patiently waited. The tank advanced, and a shot ripped through the sandbags, showering debris. At 150 meters, it was still too early. At 100 meters, it was ideal. Funk raised his M9A1. Private John McKay, the loader, slid in an M6A3 round and gave a light tap on Funk's shoulder, signaling readiness. He aimed at the Panther's lower hull, where the armor thickness was roughly 40 millimeters. He squeezed the trigger, and the shot was fired. The projectile's flight lasted about 1 2/10 seconds. It impacted the side of the tank just below the turret, followed by a flash and smoke. The vehicle rolled a few more meters without immediately stopping. "Mistake?" McKay inquired. "Hit," Funk replied calmly. "Watch." White smoke, then black smoke, began to pour from the hatches. The crew disembarked. The Panther halted and then caught fire. The second Panther, witnessing this, turned and retreated. Later, American forces inspected the tank's side, noting a clean hole approximately 7 centimeters in width. The shaped charge jet had penetrated the armor, reached the ammunition storage, and ignited the shells. The internal explosion tore the tank apart from within. Many German tanks met their end in Normandy in this manner, not from tank guns or aerial attacks, but from infantry armed with bazookas lying in ambush at the opportune moment. Tank crews of the Third Reich began to fear not just the Sherman tanks, but also the American soldiers fighting alongside them. In September of 1944, the United States Army Ordnance Department released an internal review detailing the effectiveness of anti-tank weaponry in Europe. The data, covering France from June to August, indicated that bazookas and other handheld anti-tank weapons accounted for 412 destroyed German tanks and self-propelled guns, while American tanks destroyed 347, anti-tank guns 289, and aviation 198, for a total of 1,468 vehicles. A bazooka, an infantryman's weapon costing $18, achieved more tank kills than the Sherman tank, which had a cost of approximately $50,000. However, there was a significant human cost associated with this success. For every 100 tanks destroyed, bazooka crews suffered 43 killed and 87 wounded, totaling 130 casualties. In comparison, Sherman tank crews experienced 12 killed and 31 wounded per 100 tanks destroyed, totaling 43 casualties. The bazooka effectively neutralized armor, but the risk to the operator was immense. Approaching within 50 to 100 meters of a tank required either exceptional bravery or utter desperation. Sergeant Funk, the same soldier who had disabled a Panther near Saint-Lô-Constant, wrote home, "Shooting a bazooka at a tank is like standing on the tracks and waiting for the train to come close enough to throw a stone. Throw too early, and you miss. Too late, and it crushes you." Nevertheless, soldiers continued to fire because the bazooka offered a fighting chance. Without it, infantrymen were defenseless against tanks. With it, they had an answer. The psychological impact was immense. Tank crews were acutely aware of this. Captain Hans von Luck, a battalion commander in the 21st Panzer Division, recalled, "In Russia, we feared the T-34 and its guns. In France, we feared every window, every bush, every shattered wall, because from there, a bazooka could fire, and if it fired from 30 meters, no armor could save you." Tactics began to adapt. German forces avoided towns without robust infantry support, skirted narrow streets, and fired at any suspicious window. This caution slowed their advance and reduced their overall effectiveness, and Germany was running out of time. December of 1944 marked the Ardennes offensive, Hitler's final significant attempt to reverse the war's tide in the West. More than 1,000 tanks were deployed, including King Tigers, boasting 150 millimeters of frontal armor. On the 16th of December, German forces breached the Ardennes, striking a vulnerable sector. The Panzerwaffe advanced approximately 80 kilometers deep. American units retreated, but they did not abandon their bazookas. As enemy armor entered the villages, they were met with determined resistance. In Bastogne, on the 20th of December, the 101st Airborne Division found itself encircled. They were equipped with approximately 60 M9A1 bazookas and around 500 rounds. The Germans launched an assault on the town, with Panthers and Panzer IVs entering the streets. These were met with fire from windows, basements, and rubble piles. On the first day, the Americans disabled 18 enemy vehicles, 11 of which were attributed to bazooka fire. The critical issue was ammunition. By the 22nd of December, fewer than 100 rounds remained for the entire division. On the 23rd, the skies cleared and transport aircraft delivered supplies, including food, medicine, ammunition, and an additional 400 bazooka rounds. Soldiers embraced the dropped containers. The bazooka was their lifeline. By the end of December, the offensive had stalled. German tank losses amounted to hundreds, with precise figures lost in the winter woodlands. Repeatedly, field reports highlighted one word: bazooka. One particular incident became legendary. On the 24th of December, in Chenogne, Private Robert Max, a 19-year-old soldier, occupied a position with a bazooka in the ruins of a church. A King Tiger, a massive 68-ton behemoth with 150 millimeters of frontal armor, lumbered down the road. Max knew his M6A3 round could penetrate approximately 150 millimeters. The front of the tank was impenetrable. The side armor was about 80 millimeters thick. He waited until the tank passed him, then stepped onto the road behind it. The distance was approximately 20 meters. He targeted the rear plate where the fuel tanks were located and the armor was thinner. He fired. The projectile struck the rear plate, and the shaped charge jet pierced the steel, igniting the fuel. The resulting explosion threw Max to the ground. He was later awarded the Silver Star for his actions. Most importantly, he survived because he had a bazooka. By January of 1945, Germany was on the verge of defeat. The Red Army was 60 kilometers from Berlin, and the Americans had reached the Rhine. Yet, factories continued to produce Panzerfausts by the millions. By the time of capitulation, approximately 6 7/10 million launchers of various models had been manufactured. The Panzerfaust 30 offered an effective aimed range of about 30 meters, the Panzerfaust 60 up to 60 meters, the Panzerfaust 100 up to 100 meters, and the Panzerfaust 150 was an experimental, reusable variant. Every German infantryman, even members of the Volkssturm, possessed anti-tank capabilities, but this no longer altered the war's outcome. The fundamental problem was not the absence of effective weaponry, but the critical loss of strategic time. When the Americans initiated mass production of bazookas in 1942, they secured a 3-year advantage, a period during which their infantry had a viable countermeasure against German tanks. By 1944 to 1945, when the Germans finally fielded truly massive quantities of Panzer variants, it was too late. The Allies dominated the skies. Their supply lines stretched without end, and artillery systematically neutralized any resistance. A Panzerfaust in the hands of a militiaman could destroy a single vehicle, but it could not stop an advancing army. The chilling irony was that the Panzerfaust was technically superior to the bazooka. It boasted greater penetration capabilities, approximately 200 millimeters compared to the bazooka's roughly 150, featured simpler construction, was designed for single use, and was significantly less expensive, costing around 30 Reichsmarks versus the bazooka's approximately $50. The Germans had learned the lesson of mass production and embraced simple, cost-effective designs. However, this realization arrived 3 years late. Those 3 years were the decisive factor in their defeat. Europe was effectively lost. The Panzerfaust appeared as Germany was retreating on all fronts, its factories subjected to nightly aerial assaults, and its raw material supply critically depleted, even for tank production. By this stage, the Americans had already produced approximately 460,000 bazookas. The Germans' decision to ramp up mass panzer production occurred precisely when time had turned against them. The 6th of June, 1944, D-Day, the Normandy landings. American forces landed on Omaha and Utah beaches. Although each infantry company carried bazookas, their utility on the beaches was minimal. The defenses comprised concrete bunkers and casemates, not armored vehicles. A shaped charge was highly effective against steel, but could not penetrate a meter of concrete. The bazookas would prove their worth later, as the beachhead expanded and Allied columns encountered German tanks. On the 18th of June, at Saint-Lô-Constant, about 15 kilometers from the coast, Able Company of the 505th Parachute Infantry Regiment established defensive positions on the outskirts. Facing them were 2 Panther tanks and a platoon of German infantry. Sergeant Leonard Funk spotted the first Panther emerging from behind a farm building at an approximate distance of 200 meters. This range exceeded the bazooka's effective engagement capability, which was about 100 meters. He waited patiently. The tank advanced, and a shot tore through the sandbags, showering debris. At 150 meters, it was still too early. At 100 meters, it was perfect. Funk raised his M9A1. Private John Mackay, the loader, slid in an M6A3 round and gave a light tap on Funk's shoulder, indicating readiness. He aimed at the Panther's lower hull, where the armor was approximately 40 millimeters thick. He squeezed the trigger, and the shot was fired. The projectile's flight took roughly 1 2/10 seconds. It struck the side of the tank just below the turret, followed by a flash and smoke. The vehicle rolled a few more meters before coming to a stop. "Missed?" Mackay inquired. "Hit," Funk replied calmly. "Watch." White smoke, then black smoke, began to emanate from the hatches. The crew exited the tank. The Panther halted and then erupted in flames. The second Panther, witnessing this, turned and retreated. Later, American forces examined the tank's side, noting a clean hole approximately 7 centimeters wide. The shaped charged jet had penetrated the armor, reached the ammunition rack, and ignited the shells. The internal explosion tore the tank apart from within. Many German tanks met their end in Normandy in this manner, not from tank guns or airstrikes, but from infantry armed with bazookas patiently waiting in ambush. German tank crews increasingly feared not the Shermans themselves, but the American soldiers fighting alongside them. In September of 1944, the United States Army Ordnance Department published an internal review assessing the effectiveness of anti-tank weapons in Europe. The statistics for France, from June to August, showed 412 tanks and self-propelled guns destroyed by bazookas and other handheld anti-tank weapons, 347 by American tanks, 289 by anti-tank guns, and 198 by aviation. A bazooka, an infantryman's weapon costing $18, accounted for more kills than the Sherman tank, which cost approximately $50,000. However, there was a significant human price for this success. Bazooka operator losses per 100 tanks destroyed were 43 killed and 87 wounded, totaling 130 casualties. In contrast, Sherman crew losses per 100 tanks destroyed were 12 killed and 31 wounded, totaling 43 casualties. The bazooka effectively stopped armor, but the risk to the shooter was immense. To approach within 50 to 100 meters of a tank required either extraordinary bravery or pure desperation. Sergeant Funk, the same soldier from Saint-Lô-Constant, wrote home, "Shooting a bazooka at a tank is like standing on the tracks and waiting for the train to come close enough to throw a stone. Throw too early, you miss. Too late, and it crushes you." Yet, soldiers continued to fire because the bazooka offered a chance. Without it, infantry was helpless before armor. With it, they had an answer. The psychological effect was profound. Captain Hans von Luck, commander of a battalion in the 21st Panzer Division, recalled, "In Russia, we feared the T-34 and its guns. In France, we feared every window, every bush, every shattered wall, because from there, a bazooka could fire, and if it fired from 30 meters, no armor could save you." Tactics began to change. Germans avoided towns without strong infantry screens, skirted narrow streets, and fired at every suspicious window. This maneuver slowed their movement and reduced their effectiveness, and Germany was running out of time. December of 1944 saw the Ardennes offensive, Hitler's last major gambit in the West. More than 1,000 tanks were deployed, including King Tigers, with 150 millimeters of frontal armor. On the 16th of December, the Germans broke through the Ardennes, striking a weak sector. The Panzerwaffe pushed approximately 80 kilometers deep. American units retreated, but they did not abandon their bazookas. As enemy armor entered the villages, they encountered resistance. In Bastogne, on the 20th of December, the 101st Airborne Division was encircled. They possessed around 60 M9A1 bazookas and roughly 500 rounds. The Germans attempted to take the town by storm. Panthers and Panzer IVs entered the streets, only to be met with fire from windows, basements, and barricades. On the first day, the Americans disabled 18 enemy vehicles, 11 of which were attributed to bazookas. The problem was ammunition. By the 22nd of December, fewer than 100 rounds remained for the entire division. On the 23rd, the skies cleared. Transport aircraft dropped supplies, including food, medicine, ammunition, and an additional 400 bazooka rounds. Soldiers embraced the containers. The bazooka was their lifeline. By the end of December, the offensive stalled. German tank losses reached hundreds. Precise figures were lost in the winter woods. Yet again and again, field reports mentioned one word: bazooka. One episode became legend. On the 24th of December, in Shanonia, Private Robert Max, a 19-year-old soldier, took position with a bazooka in the ruins of a church. A King Tiger, a 68-ton behemoth with 150 millimeters of frontal armor, lumbered down the road. Max knew his M6A3 round penetrated approximately 150 millimeters. The front of the tank was an impossible target. The side armor was roughly 80 millimeters. He waited until the tank rumbled past, then stepped onto the road behind it. The distance was about 20 meters. He aimed at the rear plate, where the fuel tanks were located and the armor was thinner. He fired. The projectile struck the rear plate, and the shaped charge jet punched through, igniting the fuel. The explosion was so violent that the shockwave threw Max to the ground. For that shot, he received the Silver Star. Most importantly, he was alive because he had a bazooka. January of 1945. Germany was losing. The Red Army stood 60 kilometers from Berlin. The Americans were on the Rhine, yet factories still smoked, stamping out Panzerfausts by the millions. By capitulation, approximately 6 7/10 million launchers of various models had been produced. The Panzerfaust 30 offered an effective aimed range of about 30 meters, the Panzerfaust 60 up to 60 meters, the Panzerfaust 100 up to 100 meters, and the Panzerfaust 150 was an experimental, reusable model. Every German infantryman, even those in the Volkssturm, possessed anti-tank capabilities in their hands, but it no longer changed the war's outcome. The problem was not the absence of a means, but the loss of strategic time. When, in 1942, the Americans launched mass bazooka production, they gained a 3-year advantage, 3 years during which their infantry had an answer to German tanks. When, in 1944 to 1945, the Germans finally fielded true masses of Panzer variants, it was already too late. The Allies held the skies. Their columns stretched without end. Artillery erased resistance. A Panzerfaust in the hands of a militiaman could kill a single vehicle, but not stop an army. And here lies the chilling irony. The Panzerfaust was technically stronger than the bazooka, greater penetration, about 200 millimeters, versus roughly 150, simpler construction, single use, and a lower price, on the order of 30 Reichsmarks versus about $50. The Germans learned the lesson and built simple, cheap mass weapons. But they learned it 3 years too late. And those 3 years are the answer to why they lost. Europe was almost lost already. The Panzerfaust appeared when Germany was retreating on all fronts, when its factories were hammered nightly from the air, when raw materials were scarce, even for tanks. By that time, the Americans had produced about 460,000 bazookas. The Germans ramped up mass panzer production at the moment when time itself had turned against them. The 6th of June, 1944, D-Day, the Normandy landings. American forces stepped onto Omaha and Utah beaches. Each infantry company carried bazookas, but on the beaches, they were almost useless. The defenses were concrete bunkers and casemates, not armor. A shaped charge cuts through steel, but not through a meter of concrete. The bazookas would prove their worth later when the beachhead expanded and tanks appeared. The 18th of June, Saint-Lô Constant. about 15 kilometers from the coast. Able Company of the 505th Parachute Infantry Regiment holds the outskirts. Opposite them, 2 Panthers and an infantry platoon. Sergeant Leonard Funk spots the first Panther emerging from behind a farm, roughly 200 meters away. Too far. The real effective range is about 100 meters. He waits. The tank advances. A gunshot rips the sandbags apart. 150 meters. Too soon. 100. Perfect. Funk lifts the M9A1. The loader, Private John McKay, slides in an M6A3 round and gives a light tap on the shoulder. Loaded. He aims at the Panther's lower hull, where the armor is about 40 millimeters. A squeeze and the shot. The flight lasts roughly 1 2/10 seconds. Impact on the side just below the turret. A flash. Smoke. The machine rolls a few more meters, not stopping immediately. Missed? McKay asks. Hit, Funk replies calmly. Watch. White, then black smoke flows from the hatches. The crew climbs out. The Panther halts, bursts into flames. The second Panther sees this, turns, and retreats. Later, the Americans examine the side, a neat hole about 7 centimeters wide. The shaped charge jet pierced the armor, reached the ammunition rack, and ignited the shells. The internal blast tore the tank apart from within. Many German tanks die this way in Normandy, not from tank guns or airstrikes, but from infantry with bazookas waiting patiently in ambush. German tankers now feared less the Shermans and more the American soldiers beside them. September of 1944, the Ordnance Department of the United States Army publishes an internal review of anti-tank weapon effectiveness in Europe. Data for France, June to August. Destroyed by bazookas and other handheld anti-tank weapons, 412. By American tanks, 347. By anti-tank guns, 289. By aviation, 198. Total, 1,468. A bazooka, an infantryman's weapon costing $18, accounts for more kills than the Sherman tank, which costs about $50,000. But there is another price. Human losses among bazooka crews per 100 tanks destroyed. Killed 43, wounded 87, total 130. Losses among Sherman crews per 100 tanks destroyed. Killed 12, wounded 31, total 43. The bazooka stops armor effectively, but the risk to the shooter is immense. To approach within 50 to 100 meters requires either great bravery or pure desperation. Sergeant Funk, the same man from Saint-Lô-Constant, writes home, "Shooting a bazooka at a tank is like standing on the tracks and waiting for the train to come close enough to throw a stone. Throw too early, you miss. Too late, and it crushes you." And yet soldiers fire because the bazooka gives a chance. Without it, infantry is helpless before armor. With it, it has an answer. The psychological effect is enormous. Captain Hans von Luck, commander of a battalion in the 21st Panzer Division, recalls, "In Russia, we feared the T-34 and its guns. In France, we feared every window, every bush, every shattered wall, because from there, a bazooka could fire. And if it fired from 30 meters, no armor could save you." Tactics change. Germans avoid towns without close infantry screens, steer clear of narrow streets, and fire at every suspicious window. Movement slows, efficiency drops, and Germany has no time left. December of 1944, the Ardennes Offensive, Hitler's last great gamble in the West. More than 1,000 tanks go into action, including King Tigers with 150 millimeters of frontal armor. On the 16th of December, a strike through the Ardennes against a weak sector. The Panzerwaffe push about 80 kilometers deep. American units fall back, but they do not abandon their bazookas, and when the armor enters the villages, it meets resistance. Bastogne, the 20th of December. The 101st Airborne Division is encircled. They have around 60 M9A1s and roughly 500 rounds. The Germans assault the town. Panthers and Panzer IVs enter the streets. In response come shots from windows, basements, and rubble piles. On the first day, the Americans knock out 18 vehicles, 11 with bazookas. The problem is ammunition. By the 22nd of December, fewer than 100 rounds remain for the entire division. On the 23rd, the skies clear. Transport aircraft drop supplies, food, medicine, ammunition, and another 400 bazooka rounds. Soldiers embrace the containers. The bazooka is their lifeline. By the end of December, the offensive stalls. German tank losses reach hundreds, exact figures lost in the winter woods. But again and again, the field reports mention one word: bazooka. One episode becomes legend. The 24th of December, Chenone. Private Robert Max, 19 years old, waits with a bazooka in the ruins of a church. A king tiger crawls along the road, a 68-ton giant with 150 millimeters of frontal armor. Max knows his M6A3 penetrates about 150 millimeters. The front is hopeless, the side roughly 80. He waits until the tank passes, steps onto the road behind it. Distance 20 meters. Target the rear plate, fuel tanks and thinner armor. Shot. Impact. The shaped charge jet cuts through the steel and ignites the fuel. The explosion throws Max to the ground. Later, he receives the Silver Star. And most importantly, he lives because he had a bazooka. January. Germany is losing. The Red Army is 60 kilometers from Berlin. The Americans are on the Rhine, but factories still smoke, stamping out Panzerfausts by the millions. By capitulation, about 6 7/10 million launchers of various models are produced. Panzerfaust 30, range about 30 meters. Panzerfaust 60, up to 60 meters. Panzerfaust 100, up to 100 meters. Panzerfaust 150, experimental reusable. Even the lowest infantry soldier, including those in the Volkerm formations, was equipped with an anti-tank weapon, yet this no longer altered the war's trajectory. The fundamental issue wasn't a scarcity of armaments, it was a deficit of time. When the Americans initiated their massive bazooka production in 1942, they secured a 3-year lead. For 3 years, their ground forces possessed an effective countermeasure against armored vehicles. By the time the Germans finally achieved mass production of the Panzerfaust between 1944 and 1945, it was considerably too late. The skies were dominated by the Allied forces. Their supply lines formed interminable ribbons across the landscape, and their artillery relentlessly bombarded the terrain. A Panzerfaust in the hands of a militia fighter could indeed destroy a single tank, but it was incapable of halting an entire army. And herein lies a bitter paradox. The Panzerfaust was technically superior to the bazooka. It boasted greater penetration capabilities, approximately 200 millimeters compared to 150. Its design was simpler, intended for single use, and it was more cost-effective, costing around 30 Reichmarks as opposed to $50. The Germans had finally grasped the principle of simplicity, affordability, and mass production. However, they had learned this lesson 3 years too late, and those 3 years proved decisive in determining the war's outcome. It was April of 1945, the final month of hostilities in Europe. The Red Army launched its offensive against Berlin, comprising approximately 2.5 million personnel, over 6,250 tanks, and roughly 7,500 aircraft. The defending forces numbered around 500,000. This engagement represented the war's last widespread deployment of shaped charges and was also its most brutal. Soviet tank crews encountered Panzerfausts on every thoroughfare, from every window, and behind every makeshift barricade. 16-year-old boys and 60-year-old grandfathers, part of the Volkssturm, fired at T-34 and E-Bots-2 tanks from distances of about 30 meters. Tank losses were extensive, numbering in the many hundreds. For Berlin alone, over 800 vehicles were lost, with a significant portion attributed to the Panzerfaust. Nevertheless, it could no longer save Germany. For every T-34 destroyed, 2 new ones were produced. For every soldier fallen, 10 were conscripted. The industrial might of both the East and the West crushed resistance far more rapidly than it could be inflicted. On April 30th, Hitler took his own life in his bunker. On May 8th, Germany surrendered, marking the end of the war in Europe. Allied depots held approximately 340,000 bazookas and 12 million rounds of ammunition. German stockpiles contained roughly 2 million Panzerfausts, which were now rendered useless. Both weapon systems had served their purpose. The bazooka provided American infantry with a 3-year advantage in countering armored threats. The Panzerfaust offered German infantry a similar capability, but its late arrival rendered it ineffective. The war concluded, but the narrative of shaped charges was just beginning. It was the summer of 1945. Allied engineers meticulously examined captured enemy equipment. Soviet designers collected everything, both German and American designs. In the Soviet Union, the RPG-2 emerged, a Soviet reimagining of the Panzerfaust. This was later followed by the RPG-7, a design that would become the most extensively utilized anti-tank weapon of the 20th century. In the United States, the bazooka underwent further refinement. The M20 Super Bazooka entered production after the war, featuring an 89mm caliber capable of penetrating up to 280mm of armor and seeing action in Korea and Vietnam. The British developed the Piat, their unique approach utilizing a spring-loaded mechanism to project a shaped charge without rocket propulsion. The French, Chinese, Czechs, and Poles each established their own national versions. The shaped charge transitioned from a closely guarded secret to a standard infantry weapon. Modern weaponry, such as the RPG-7, AT-4, NLAW, and Javelin, all operate on the fundamental principle first described by Captain Munroe in 1888, a copper liner, an explosive charge, and a focused jet. Tandem warheads were introduced to overcome reactive armor, and guidance systems and fire-and-forget capabilities were developed. Yet, the core principle remains unchanged, a straightforward physical effect that empowers an infantryman to engage a tank. Let us return to the outset. It was September of 1943. German engineers, examining a disassembled bazooka, struggled to comprehend how something so rudimentary could be so effective. The issue was not a lack of knowledge, as Carl Neumann had patented the concept back in 1914, 28 years before the American assembly line began production. Nor was it a technological deficit. German industry in the 1940s was the most advanced in Europe. The failure lay in their philosophy, a fixation on perfection. Each design was treated as a masterpiece: the Tiger tank, a benchmark of engineering; the Panzerschreck, the pinnacle of performance. However, striving for such superiority demanded extensive time and resources. The Americans embraced pragmatism. Their solutions were not flawless. The Sherman tank was outmatched by the Panther in a frontal engagement, and the bazooka lagged behind the Panzerschreck in penetration and range. Yet, the Sherman could be produced in 50,000 units, and the bazooka in 500,000. Quantity ultimately triumphed over quality. Albert Speer would later lament, "We spent months perfecting every screw. The Americans simply produced good enough and outpaced us tenfold. By the time I grasped this, it was too late." Thus, the bazooka's legacy is a testament to the strategic importance of speed and scale. Furthermore, there are psychological impacts that statistical data cannot capture. The bazooka fundamentally altered morale. Imagine yourself as a soldier in a narrow French street. Around a corner, a 30-ton behemoth armed with a 75mm gun appears. Without a bazooka, your only recourse is to flee. With one, you possess an option. The risk of death does not vanish, but the possibility of resistance emerges. As General Funk stated in an interview in the late 1970s, the bazooka did not make me immortal. It gave me a chance. In war, a chance is everything. American soldiers placed their faith in this weapon not because it was infallible, but because it was present in every company, in every platoon. This meant that when a tank appeared, a response was readily available. German infantry experienced a prolonged period of helplessness against armor until the Panzerfaust's introduction in 1944. Their anti-tank rifles were ineffective against even a Sherman, and their larger guns were too cumbersome for urban combat. This fostered a pervasive sense of fear. For the Americans, the situation was reversed. A feeling of helplessness transmuted into proactive engagement. The story of the bazooka mirrors the broader narrative of the war. On one side stood Germany, with its exceptional engineers, sophisticated factories, and a pursuit of perfection, possessing theoretical advantages decades ahead of its time and technically superior weaponry, but having lost critical time. On the other side, the United States, not necessarily the most refined in its engineering, yet characterized by pragmatism and the efficiency of the assembly line. An idea from a Swiss immigrant, Henry Mohaupt, was transformed into a mass-produced product within a year. The M1 was far from perfect. It had limitations such as short range, modest accuracy, and a dangerous backblast. The Germans, confident in their superior capabilities, scoffed. "We will make it better," they declared. And they did, but they did so too late. By the time their improved weapons were ready, the Americans already possessed hundreds of thousands of bazookas in combat. Victory belonged not to absolute quality, but to timely deployment. Captain Charles Munroe, who in 1888 elucidated the cavity effect, could never have envisioned how his theoretical principles would reshape front lines. Carl Neumann likely never imagined the eventual impact of his patent. Henry Mohaupt did not foresee how many lives his rudimentary sketch would ultimately save. Physics is a patient force. The effect of the shaped charge had always existed, merely awaiting its opportune moment. When that moment arrived, a simple copper cone and an explosive charge fundamentally shifted the balance of power. They provided infantry with a fighting chance, making warfare marginally less desperate. The bazooka did not win the war on its own. Millions of individuals, thousands of machines, air superiority, artillery, logistics, and strategy all played crucial roles. However, the bazooka offered a ray of hope to those who faced armored vehicles directly, and at times, that possibility is the very distinction between life and death. Today, in a museum display, we see a scuffed M9A1 tube and find it difficult to believe that such a simple device could have profoundly influenced a continent. German engineers at the Kummersdorf facility viewed it differently, realizing their defeat stemmed not from technical deficiencies, but from a flawed approach, because sometimes good enough triumphs over perfection. Speed becomes a measure of quality. Simplicity embodies complexity. Munroe did not know the future applications of his work. No man did not anticipate its ultimate destination. Mohaupt did not plan for the sheer scale of its adoption. They were simply engaged in their respective tasks, and history made its choice. The bazooka was significant not because it was the absolute best, but because it was available when needed. And therein lies the fundamental lesson. The perfect weapon that arrives too late is superseded by a sufficient one that is present today. The perfect strategy meticulously planned over years yields to one that is already in effect. The perfect solution that remains unbuilt is inferior to an ordinary one deployed in the field. The Germans pursued perfection, while the Americans aimed for results. The war unequivocally demonstrated which approach was correct. The copper liner, a simple component stamped like a tin can, became an emblem of pragmatism, ultimately overcoming perfectionism. When the engineers at Kummersdorf examined the disassembled bazooka, they did not marvel at its penetration power. Their astonishment stemmed from the realization that simplicity had overturned everything they held true, and it was precisely this simplicity that ultimately prevailed.